If you're investing, trading, or building in Web3, knowing how to read blockchain data directly is your baseline for survival. It's also where a lot of beginners make choices that create problems later. Trusting delayed aggregators, confusing proxy contracts with implementations, or getting lost in cross-chain transactions when data is smeared across a dozen roll-up networks. This guide covers how smart contract analytics actually works in 2026, the standards behind the data, the two main implementation paths for extracting it, and what to watch out for once you start analyzing real wallets and protocols. What's actually happening on-chain? Before opening any dashboards, it's worth understanding the mechanism. Blockchains don't store data in convenient tables. They store state and event logs. When a user executes a swap on Uniswap, the smart contract updates user balances, the state, and emits an event, such as a swap, the log. Your analytical tool takes these raw, unstructured hexadecimal logs, decodes them using the contract's ABI, application binary interface, and turns them into a readable history. That's the core loop. Everything else, aggregating volumes, tracking whales, calculating P&L, builds on top of that initial decoding handshake. The fragmentation problem and AI-assisted analytics for years, the standard approach was writing custom subgraphs via the graph or manually parsing Etherscan. That worked when 90% of the activity was on Ethereum mainnet. It stopped working when liquidity migrated to Base, Arbitrum, Optimism, and various ZK EVMs. Querying data manually became impossible. In 2026, multi-chain indexing with AI assistance is the production standard. Instead of writing complex TypeScript scripts to scrape data yourself, modern platforms have already indexed all EVM chains into unified databases. You simply query them. Two approaches: hosted platforms versus raw indexers. You have two main paths for implementation. You can use visual analytics platforms, writing SQL queries, or using natural language prompts to generate charts. Or you can use indexer infrastructure to pull raw data directly into your own codebase or backend. The hosted platform approach gives you instant visual results and no infrastructure overhead. It's appropriate for traders, researchers, and product analysts. The indexer approach gives you programmatic control and real-time latency. It's appropriate for developers building their own DApps or trading bots. In 2026, the two dominant options representing these paths are Dune Analytics and Envio or Goldsky. Dune Analytics, the standard for analysts. Dune is a platform that translates blockchain data into standard relational databases. It allows you to query smart contract data the same way you would query a normal PostgreSQL database. The workflow takes 3 steps. First, find the target smart contract, like a liquidity pool, on a block explorer and copy its address. Second, write a query in Dune SQL. Dune's engine automatically unifies data across L2s if you use cross-chain tables. Built-in LLMs can also generate the bulk of the SQL code if you simply describe what you want. For example, show me the daily trading volume of token X on Base over the last month. Third, visualize the result and save it to a dashboard. Dune is the recommended path for deep research. You don't need to spin up nodes or worry about storing terabytes of historical blockchain data. Next-gen indexers, Envio, Goldsky. The direct approach. If you're building an application, you don't need charts, you need a reliable API. The old methods of calling ETH_GET logs directly via RPC providers are slow and frequently time out over large block ranges. In 2026, developers use hyperfast indexers like Envio. The workflow here is explicit. You create a config file specifying the contract addresses and the specific events you want to track. You provide the ABI. The indexer then spins up and generates a typed GraphQL API for you to consume. Unlike older solutions, modern indexers process thousands of blocks per second and support real-time webhooks. This is the right choice when you need millisecond-level access to on-chain events for your backend, or when you are building a custom notification system for your users. Common issues in production proxy contracts. This trips up most beginners. Modern protocols heavily utilize the proxy pattern. When you look at a contract address, you only see the routing logic, not the actual functions. You must find the underlying implementation contract to read the correct ABI and decode the data. The decimals problem. EVM chains do not use floating point numbers. Tokens use the WEI format. If you see a transfer amount of 1 quintillion, that is usually just one token with 18 decimals. Forgetting to divide the raw data by the correct number of decimals will result in charts where volumes look quintillions of times larger than reality. Handle this explicitly in your SQL query or parser logic. MEV and arbitrage noise. If you are analyzing DEX volume, up to 60% of the transactions might be MEV bots, sandwich attacks, arbitrage. If you don't filter out transactions where the sender is a known bot contract, your data on real user behavior will be wildly distorted. Spam and spoofed tokens. Anyone can create a token with the ticker USDC and send it to a known whale's address. The blockchain will faithfully record this event. If your query doesn't explicitly filter for the verified original USDC contract address, your analytics will show that a whale just bought millions of dollars of a garbage asset. Labels and attribution. Nansen. Reading raw 0x addresses is mostly useless for market intelligence. Tools like Nansen or Dune's integrated spellbook labels solve this by providing attribution. They link addresses to entities, exchanges, funds, known exploiters, or smart money. If you are doing analytics for trading, joining your raw event logs with label tables is what turns a basic chart into an actionable insight. What to test before publishing. Test a random day on your chart and compare it against a reputable aggregator like Dfalama. Manually verify a specific transaction from your dataset using a block explorer. Do the amounts and addresses match exactly? Test for edge cases. During days of extreme network volatility, ensure your script isn't counting failed, reverted transactions as successful actions. The data extraction layer is the foundation of your research. Getting it right means fewer false signals, fewer broken dashboards, and a significantly better understanding of what is actually happening on-chain.